Hello, everyone. Welcome to this week's stream of The Context. If you're joining us for the first time, we are here to talk about all things MCP, and you can check out some of our previous streams on our YouTube channel. But brand new episode this week, and if you've tuned in before, you might not recognize me. I'm filling in for Shannon today. My name's Connie. I am on Shannon's team here at Acorn. Shannon's on vacation, so I'll be here chatting it up with Darren, our chief architect, as always. And we're joined by our speakers here today, Johnny, industry analyst from India, and we also have Amanda from Apollo GraphQL. And she's actually filling in for Michael, if you guys were looking at the description earlier this week, just a last minute speaker change, but all the same topics. So let's get into it. Wanted to cover a few things before we get into our sessions. October 2nd, we're hosting our second MCP Dev Summit in Europe. So if you wanted to sign up, if you missed the one in San Francisco, go to mcpdevsummit.ai. You can get registered. We have our early bird rate now through the end of August, so make sure to snag that. It's 200 pounds for the registration fee right now. We're also taking talk submissions. So if you have anything you'd like to share that you're building around MCP, make sure to submit that through our portal. We're taking submissions until August 17th. So a couple weeks left for that. As always, you can check out our YouTube for our recent episodes. Scan the QR code there. Here's a preview of what's coming next. We have a stacked lineup, honestly, through probably mid to late September. Lots of content out there for MCP, so super excited about that. If you're interested in talking on the context, go ahead and submit. You can scan that QR code here, and then we can get you scheduled. So today's talks, we have two. They're both going to be about 20 minutes. Pretty interactive. If you have any questions, pop them into the chat and we'll try to get to them at the end of each segment. And let's go ahead and get started. So our first speaker today is Johnny. He's an industry analyst from India. And we'll kick it off with him and then jump into Amanda's segment after. So Johnny, go ahead and let's get you rolling.
Thanks, Connie. Let me share my screen and let me start off with Elicitation. So
Great.
I'm assuming all the viewers are familiar with MCP protocols, but the most recent update that took place on 18 June came out with a very interesting new feature called Elicitation. It's a part of the new spec, not implemented yet. It's currently in draft. But what this basically brings is the ability to bring human into the loop. So typically, when we use an MCP server and an MCP client, we pass the parameters directly to the tool, but there may be some interactions or some scenarios where we may have to prompt the user and get their input. For example, you are implementing an expense management tool and you want to send the approval over Slack to the manager and wait for him to come back. So the manager will take a look at the expense statement. He will verify the bills if he wants to, and then he'll approve it. And once the approval is done, the MCP tool will resume and it will process the rest of the tool or the workflow. So if that is the scenario, till date, MCP didn't have the ability to put the human in the loop. But with the user interaction model and elicitation, there is a opportunity, there is a chance for us to bring user into the overall flow. So this is how it works. We basically have the client initiate a session and then register its elicitation callback. And when the server has to elicit input, it will send it to the client, and client will present it to the user. This is completely agnostic. It could be a console simple prompt input, or it could be Slack, Microsoft Teams, or WhatsApp. It doesn't really matter, but you can basically escalate this message all the way to the user interface and wait for the user to interact with it. So this is dynamic mechanism of accepting the parameters instead of hardwiring them and sending it directly to the server from the client. So one of the very important aspects of elicitation is the streamable HTTP protocol. If we don't understand how streamable HTTP works, then it is very hard for us to understand how elicitation works. So I'm going to first show you the streamable HTTP workflow back and forth between the client and server. And then I will actually implement an elicitation and show you how it works. So let me start with my first demo, which is the streamable HTTP and dissecting the entire flow. So I have a very simple MCP server and client. So here is my MCP server. It basically has a list of dictionaries. So it sends fictitious employee names and the roles. That is the tool that I'm implementing. And I'm implementing HTTP, which is Streamable HTTP protocol instead of STDIO. By the way, elicitations work with STDIO, but it's far more transparent and far more easier to understand if you look at the Streamable HTTP protocol, the transport protocol instead of STDIO. So this is my most simplified MCP server, and then I have the MCP client, and this MCP client talks to Gemini, the multimodal AI model from Google. So here I basically send a prompt that says who is the intern in the company, and we expect Eve to come back as the intern, which is a part of the tool workflow. So this is an end-to-end example where we have three actors: the LLM, which is Gemini, the MCP client, which is what you're looking at, and then the MCP server. So let me first show you what happens when we actually use Streamable HTTP as a protocol and make this. At this point, we are not talking about elicitation yet, but I'm currently focused more on understanding how Streamable HTTP works and why it becomes the foundation or the building block for elicitation. So let me start with that. I want to introduce a tool, which is one of my favorite tools. This is called HTTP Toolkit. It's available for Mac, both Apple Silicon and Intel. And the free version is good enough to basically intercept the traffic that goes back and forth, particularly when you're using localhost. So I'm going to start this. So I have just two files, the MCP client and MCP server. So first I'm going to start the MCP server. And now I'm going to invoke the MCP client. Now, the moment we invoke the MCP client, we see a lot of things happening on the screen. There are multiple post requests. There is one get request, and then there is one delete. Now, what exactly does this mean? And why is the client making so many calls to the streamable HTTP endpoint, which is /MCP? The first demo is about understanding this. So what I'm going to do is I will show you the HTTP toolkit intercepted output. So the first post that takes place between the client and server, let's look at the request. So the request is initialize. This is the JSON RPC request that goes from the client to the server, and server comes back with what is called as the MCP session ID. Now, this is the very first call made from the client to the server. And this is to initialize the conversation. Once the initialization is done, the session is established and we see the session ID coming back. And this is the complete context, or rather the identifier between this entire conversation that takes place between the client and server. So once the session handshake is done, then comes the event handshake. remember, streamable HTTP is about two-way communication. It is not just like, it's not stateless, it is stateful. And it is not like REST where you fire and forget. Here you basically establish a stateful connection between the client and server. So the next one is the initialization of notifications. So here we basically send the request with the same MCP session ID that was returned from the first handshake, and then we initialize the notifications. And this is a HTTP 202 accepted response, which means this is now registered. And then finally, to close this conversation, there is a get request from the client to the server again, and this establishes the channel between the client and server. So this is the content type of text event stream, and this get request ensures that any events that are lined up and scheduled by the server are sent to the client. So that is the reason why the client makes a get request. And that completes the handshake of initializing the session, the notifications, and the channel to receive server-side events, server-sent events. And then the actual work starts. The next step is to discover the available tools. So the client makes a call to this endpoint, which is tool/list. And then the response is the tool. Now, in our case, we have one tool called get employees. It comes back with that. So now the client knows that there is a tool called get employees. Now we send that to Gemini. So Gemini natively supports MCP. So in the tools parameter, I pass the session that I have established with the server. Now, Gemini knows that it can invoke the tool. So this information is passed along the prompt to the Gemini model. So the prompt here is who is the intern in the company, and the function name that is being sent is get employees. So this is simple tool calling. The only difference is it's not a embedded tool. It is coming from the server, and this get employees information came from the previous call that we saw here. So now Gemini understands that, okay, we are asking about the intern and there is a function called get employees. It comes back and then it invokes the actual tool. So this time there is a tool call method and we are invoking get employees. This is initiated by Gemini natively. And now you see that there is a JSON RPC response with all the employees coming back. This is basically the JSON packet. Now, this entire information is sent back to Gemini, and you see that it is formatted both as structured content and as plain text. This goes to Gemini, and now Gemini is well informed about finding out who is the intern in the company, and it comes back with Eve is the intern in the company. So that concludes the entire round trip and the entire workflow. And finally, because this session is done, the client calls delete, and this disconnects the client from the server sent events and also the MCP session. And this completely gets ready for the next invocation. Now, every time you invoke an MCP server from the client using streamable HTTP protocol, this is exactly the steps that it follows. Every session is re-established and this entire flow takes place. Now, why is this important for elicitation? Well, elicitation uses the server sent events mechanism for the server to push a prompt or a user input text in a very structured format, of course in JSON, to the client, and the client uses that to render. For example, it could be a pop-up dialog, it could be a WhatsApp message, it could be a Slack message. It's completely up to the developer on how he surfaces this prompt that is eliciting the user interface or the user interaction into the UI, into the user interface. And that happens because of streamable HTTP mechanism. So this is actually where the server pushes the notification to the client and it comes back as structured JSON. Now, at a high level, some of the libraries like FastMCP give us the flexibility of mapping the JSON packet and the JSON structured data structure into a native data type, a Python data type, something like a list or a dictionary or anything that you prefer, or even simple data types like string, integer, and so on. So let me show you the next demo where we implement a very simple elicitation. And this is the code for that. So I'm using Python with FastMCP. I call this as the elicitation server, and I define what is called as data class. Now, data class comes from the FastMCP library. Um, and no, actually, it is a part of the Python base library. So here we implement user info, and we call this as str and int, which are the data types. And this is going to be serialized into a JSON packet at runtime. And we have a tool which is called collect user info. Now, collect user info is not your usual tool because it is going to prompt the user to provide his name and his age. And it is going to return, hello username, you are X years old. If I want, I can cancel it as a user. I can decline to provide any input, or I can cancel the operation. Now, all of that will go back to the server, and the server can make an informed decision on how to deal with it. Now, in my case, it's a simple if-elif condition. Now, this is how I write my elicitation in the server. In the client, I have a callback handler. So here, this event, the elicitation event, is going to invoke this handler. And here I have a simple Python input method to grab the input from the user, your name, your age, and then I send the response type as simple scalar data types like name and age. So very straightforward. Now, how do I register the elicitation callback handler? Well, when I am initializing the client, I explicitly register the elicitation handler. So because of this, the server comes to know that it has to invoke this specific method. You can call it anything, but as long as it actually carries the same signature like message, which is string. Now, this is the message that we defined here. Please provide your information. This comes to the callback event as the message. Response type is the data type. Now, that's what we defined here. User info, which has name and age, and the parameters, which are the name and age that come as separate inputs, or as one data type, custom data type, if you prefer. And then there is context. We don't use it, but context will give us an opportunity to manipulate the packet as it flows back and forth. So that is how we define the communication between the server and client. So let's go ahead and run this, and I'm going to clear the interception log. Okay, and start all over again. So let me stop this and go to demo 2. Okay, so I launch my server. I have just 2 Python files here. So I'm going to launch the server, and I'm going to launch the client, and then I come back to my HTTP toolkit. Oops. Okay, now something very interesting takes place. Now you see these rotating dots. It is an asynchronous call, and the callback handler has kicked in, and it is waiting for the input. Now the first post, the session initializer, then the notification initializer, and then the get, which is basically meant for the events, and then there is a post. So all of these are exactly the same. The only difference is right after this get, it is waiting for the user input. So I'm going to input John Doe 22, and the server comes back with structured content that says result is hello John Doe, you are 22 years old. And then if you look at the workflow, it's exactly the same. The only difference is because of the server sent events, we receive the event and we wait upon the user to provide the input, and then everything else follows the same. So that is one end-to-end session with the elicitation in place. So now you understand why the streamable HTTP plays a crucial role in enabling this capability. You can also, of course, do it with stdio, but it's very hard to break it down into the exact workflow. If you're using stdio, it becomes almost like an RPC call between the client and server, and you cannot intercept this with so much of transparency and clarity. So that's why I chose streamable HTTP. But you can do this with stdio as well. And not every MCP client implements the elicitation feature because it is currently in draft. It is going to make it to the final, and then most of the clients will get updated. Currently, the native LLM clients that support MCP may or may not support elicitation because it's in the draft form of the spec. So now I want to show you more of a real world demo. So that is my third demo. And what I want to do here is show you the code first and then launch. So I want to basically write an LLM chatbot that accepts the flight information, like my flight number, and tells me the current status, whether it is delayed or scheduled or landed or en route. So it's more realistic because we need to ask for the flight number from the user. So let's take a look at the server first. Now I use an API which is called flight aware. That is not really important here. You can implement this logic the way you want it. But what I want to point is this is real time. I'm using real APIs to pull the flight information. And my data structure here is just a string. I could have avoided this and just send the string directly, but this is more of a best practice. Even if you are sending just one string back and forth, it is still a good idea to use data class because this will ensure that the MCP infrastructure is serializing the right way. And then we define a tool called getFlightStatus. And the prompt that we send, the message that we send to the end user is please provide the flight number you want to check. And response type is flight info, which is this. And then I can decline, cancel, or accept depending on the UX element I'm dealing with. And then the flight number, I have a I have a variable here where I capture, and then I continue with the asynchronous method of getting the flight status. And I also convert the time zone to the local time zone where the flight is landing. So there are some helper functions, not very important, but the ultimate goal is to get the real-time flight info by sending an elicitation to the user and get the flight number. Now, if you don't use elicitation, this flight number has to come as a parameter to the tool directly, where you can still ask the user, but it is not as elegant as this. Now, the beauty of using elicitation between MCP server and client is it is completely dynamic. We don't know whether the server is going to ask just a string or string plus an int or a complex data type. We don't know. Now, that can be found out here, that can be derived at runtime, and you can basically figure out a way to either render it dynamically or to show the most appropriate UX element and build a nice UI that lets the user select the input for the elicitation. So that was the server. Now, when it comes to client, since Gemini client, LLM client is not aware of elicitation, I am creating a helper function called send to Gemini. And this basically accepts the context, which is the complete flight data, And it also accepts the prompt, whatever I ask, like when is my flight landing and all of that. It sends the entire context to Gemini and comes back. But remaining, it's almost the same. We have an elicitation handler, which is meant for callback, and we register it along with the MCP server. And then I have a very simple UI to either invoke the tool directly or through LLM and exit. So let me execute this. I'll clear the logs, the interception logs, and I will launch the server and client again. Should be server. Okay. And then comes the client. Now, as soon as I execute the client, I have a very simple menu. Now, I can invoke the tool directly without involving an LLM. So I'm going to ask the status of one of my most frequently flown flight called EK226, that is San Francisco to Dubai, which is one of my favorite flights. So, so it comes back and prints the output. So it is currently diverted. Wow. It is supposed to be landing in Dubai at 7:30. So on 31st, but it is currently diverted. Not a good sign. So this is working. Now, when we look at the logs, again, exactly the same workflow. To post first and then a get. We haven't deleted because the session is still active. Now, what I'm going to do is I will involve the LLM and I will invoke the same tool with elicitation and send the entire context to Gemini. So here it is asking me the flight. So when is the flight landing? Now I don't give any other information because I know the UI is going to prompt me. So I'll enter EK226 and it's sending to Gemini. It comes back. The flight was scheduled to arrive. However, the flight status is diverted, which means it will not land at the originally scheduled time or destination. So now this analysis and this extra info is provided by Gemini. Now, when we look at the entire call chain, we notice that we are invoking Gemini, and if you see, it completely has the context. So the key takeaway is elicitations are built on the capability of eventing, which is delivered via server sent events and streamable HTTP. You can prompt the user at runtime, get his input. This is a great mechanism to put human in the loop. And we have seen some demos where we could elicit the user input by prompting them at runtime, and the client doesn't know, the server doesn't know, it happens completely at runtime. So that's the beauty of elicitation and the ability to bring human into the loop. So that concludes my demo.
Great. Thank you, Johnny.
That was great. I love the kind of the detail on how all that works. Demystifying it to a certain degree. There's so much, there's so many things going on in MCP to make this all happen. I mean, I think what I was kind of curious your thoughts on there's been some discussion with elicitations around kind of like private or sensitive information and whether or not that should be handled or how it might be handled going forward.
Yeah, so the spec very clearly calls out don't accept passwords, usernames, and sensitive information. There is no enforcement at this point. It doesn't really check what you are eliciting from the user. But the best practice is you should not really share sensitive information because some MCP endpoints may not even implement HTTPS, forget about OAuth. So your data is going to be flowing in plain text. So read the spec. That's the feedback I have for everyone watching this. There are some do's and don'ts. And one of the very important don't is not to use sensitive data in elicitation because there is no guarantee that it is being encrypted. So that is something that you need to be aware of.
Yeah. And one thing is, like, I think the very latest specification, it did land in the specification, right? So it is actually part of the latest MCP specification.
I need to cross check. The last I checked, it is still under draft. Maybe it made its way. Things are moving so fast that by the time I finish the demo, there will be an update.
Yeah, so I think it did. I think it did because when they released the new, they released the new spec and then they immediately copied over to draft. So we'll see it in draft. I'm pretty sure it landed in the last one. I was very early on Elicitations. I was kind of implementing it before it even, they finalized or whatever. But I think it's kind of an essential feature. I'm really excited to see the kind of enhanced interactability about MCP. I think there's really a lot of interesting aspects about it where I think it's going to turn into quite an interesting application platform. How do we build these AI applications? So
right.
Thanks. That was really good. I loved all the technical details.
Cool. Thank you.
Great. That was great. We'll see where it goes. All right. Thank you, Johnny.
Thank you.
Thanks for joining us today. Now we're going to switch over to Amanda from Apollo GraphQL. She's going to be talking about the MCP tools you can create with GraphQL. So, all right, take it away, Amanda.
All right, let's see. Let me know when my screen is being shared. Oh, perfect. I see it. All right, so I've got a couple of demos for you today I'm really excited about. I'm going to start out with a very fully open source flavor of using the Apollo MCP server, and then show you something that I built with my team for our MCP server community. So this right here, this repo that we're looking at is the Apollo MCP server. It is written against the MCP spec in Rust specifically for exposing GraphQL operations as MCP tools. And this is MIT licensed. You can go ahead and use it. So I just wanted to show you that real quick, but let's get into the code here. Where do I have it? All right. So here is a simple project setup. You can see that I have, actually, let me zoom in here for y'all. You can see that I have the binary for the MCP server kind of dropped right here in the root, and you can play around this way. If you think that you're going to be working on something that you're going to want to deploy, though, we do have this shipped as a Docker image, and that's also how we deploy our servers. So that's the way to go if you're doing anything other than just maybe like testing and exploring. But for today, we just have that binary dropped right here in the root. We're going to be looking at the GitHub GraphQL API today, which is just enormous. Like, you don't want to have to deal with this thing yourself if you can help it. So vibe coding is a great place for that. This is a great time to use that. For the MCP server, you do get to kind of configure it for what you want to do, what you want to expose. What I want to call attention to in here, in my configuration today, is there's a search and execute tool available to you. And these are the kind of tools that you're going to need to expose to your agent to be able to have this vibe coding experience. And I'll show you what I mean here shortly, but I did want to show you these are features that you can configure, so you don't have to use those. So let's go ahead and start the MCP server. I'm just pointing at that binary and my configuration file. All right, that's ready to go. And then I'm going to start up the inspector, the model context protocol inspector, and that's ready to go now too. All right, let's always want to test and make sure everything's connected. We're using streamable HTTP and the URL here with the MCP at the end, so make sure that you're pointing to those things. And we are connected, and there's those two tools available. So we're ready to go. We're not going to use those here though. Just wanted to make sure everything was up and running. You never know. My code has gone away. Let's grab it and bring it back. Where is it? Okay. All right. So this is where we get into more of the fun part here. So what we're going to use today for this is Goose. Goose is another open source product. This is an AI agent that you can configure. It's a really fun tool. We like using it here at Apollo. So if you haven't seen it before, highly recommend checking out their documentation. And you'll see how it works a little today. I'm using the AWS Bedrock model, Claude 3.7. You can configure whatever you want. This is just how I have it configured today. So now that we have our server running, we've also exposed our server in Goose. You can configure it for extensions. That's Goose's name for MCP tools. So we already have that all configured here. So now I can ask Goose to do some work for me, right? And what I want Goose to do here today is to, I need to fetch the latest 5 issues from the Apollo GraphQL. We'll do the rover repository and write the operation to a GraphQL file. So I want Goose to make me my GraphQL query. Now, Goose only has those 2 tools I showed you right now. So it's going to start grabbing the search tools. Now here, of course, is entering in a little bit of LLM magic. You don't really know how many times it's going to search. Sometimes it's really concise and it can do it in a couple of searches. Sometimes it needs to find a few more to complete your task. And you can play around with the specificity of your prompts to try to get the best results out of Goose or whatever agent that you're using. The search tool is a better implementation of introspection. So essentially, it's allowing you to search through a really large repo like this with by using those keywords that you gave it. And Goose is really getting deep in here, but this is a really big API. It's finding things. So this is kind of that unknown part and definitely gets into the more kind of prompt engineering side. So it's possible I could have given it maybe a little more information and it would have gotten there a little faster. But this is part of working with agents. You do kind of get this happening. So introspection is also a way to crawl through GraphQL APIs, but this is going to be more efficient. So we definitely recommend that. Okay, it has switched over to the execute tool, which means it has developed a query. All right, and it already wrote our file too. That's great. Let's see if it's got anything else it wants to do. It seems like it's still thinking about something, but we do already have our file, so that's exciting. All right, it's just giving us a summary. Wonderful. So it took a little while to get to it. That is using a little bit more context than I'd like. So I'd work on a better prompt. If I was going to make a lot of these, right, I'd want to get a little more specific. But it made us our query and it says that it works. It tested it with execute. This is what it made for us. Now, there's a few things I want to change in here. First of all, I am not happy with this as the name because I'm not going to just fetch rover issues. I'm going to make this a more generic tool. So let's say this will be, we'll just call it fetch GitHub issues. And we're going to drag this into the operations folder. Yes, I do. Now, you could have also added that to your prompt too, told GitHub exactly, or Goose exactly what you wanted to name it, told it where to stick the file. Again, you can kind of define those prompts however you like. But now we have this query. Now, just like you should do with anything that is vibe coded, we're going to go test this query and make sure we're happy with it too. And the best way I like to do that with GitHub, at least, is GitHub has a Explorer that they have signed me out of. All right, let's get back in. So this is just the GitHub docs. They expose this area to kind of play with your queries. So we're going to check it and see what it gives us back. All right, it definitely is working. And now from here, I want to change a few little things. Goose named this query a little bit generic for me. I want it to be really specific, that it's going to get the latest 5 issues. And then I also want to pass in variables because we're not going to leave these values here either. That was just for the initial prompt. So we're going to add owner. It's going to be a string. And it's required. We're also going to add repo name, and that's also a required string. Now we can replace these values with that owner and with that repo name. The other thing I'd like to do is just add a description. This will also be given as context for your tool to your agent of choice once it's exposed. So this will get the latest 5 issues from owner, repo name, repository. All right. So now I'm happier with this. Let's go back to our code. Now, something I want to show you that's really cool. Let's go back to where so this is the tool Goose made, right? Get latest issues. So I'm going to put my updates in here, save them, and immediately my version is hot reloaded into this, which is really sweet. It's a really fast dev experience. I really like it. Now we're going to go back to the inspector. So now let's clear these tools and list them again. We can see our newest tool here. We're going to test it out here. That's our owner. Let's try a different repo this time. Let's go with router. All right, that worked. What's in here? Okay, so I don't love the query Goose made. I feel like there's a little more in here than I need. So let's go back to our code for a second. I don't really need this URL, and I don't need all these labels. That's not really giving me any value, right? And that's the thing about this. You don't want to return a bunch of garbage. All right, we've hot reloaded. You want to return only what like your agent needs and your end user needs. You want to make everything as concise as possible. And this makes that really easy. Hot reload is there. So now I don't have to reload anything at this point. I can just run the tool again and double check that everything, yeah, I got rid of those labels, got rid of that URL. Beautiful. That is exactly what I wanted to do. You can, while this is live, add, remove fields, do whatever you need to do. You can also even completely revoke access to this tool just by moving it out of here or deleting it. I don't need it, so I'm going to just delete it. And now when you run this tool, it doesn't exist. And when you relist the tools, you can see that they are back to those original 2 tools. So you can really work really fast here to get everything configured the way you want. It's a really fast way to get up and running with an existing GraphQL API. You layer the server on top and you can just generate API or tool after tool after tool. And especially as you kind of fine tune those prompts and get it exactly what you wanted, then you have to do less work too to get these where they need to go. And again, this is all open source. Every tool that I just use are open source tools. So you can use this with or without other Apollo-based tools. Now, I want to show you one other implementation of our Apollo MCP server. So let me shut these guys down here. Is everybody shut down? Shut everything down. Okay, we are good to go there. And then I'm going to grab another repo here for you. So we have an MCP server builder series community that we actually just finished our second event in New York. Let me run this API. Hold on one second. And I'll tell you a little bit more about that. Let's get this over here too. Run this. And run this server. Okay. This should reload in a moment. There we go. Okay, that's what I wanted to show you. I couldn't talk and do this at the same time, but I'll show you what's in these guys in just a minute. Get this out of the way. All right, so we've been working in the MCP community and kind of working on building space and creating space for MCP builders. Like the conversation about elicitations a little bit ago, like you sometimes don't even know what happened yesterday in this world. And so if you're really into it, you want a place to be able to gather, whether virtually on live streams like this or in person. We actually have an event tonight in San Francisco. So if you're watching from San Francisco, we do have some more spaces and would love to have you. But in the spirit of this kind of, we're all building and learning together, we wanted to also have a tool built on the MCP server that we can evolve with the community, but the community can also use. So that's the last thing I'm going to show you. Let's see, I should be up and running here. All right. So right now, it's a fairly simple tool. We wanted to start very lightweight and kind of evolve it with the spec and with the needs of the community. You can submit a talk, manage your talks to update them, see what other people are submitting. And then we recently added just getting all events with speaking sessions. So like this was an event we had in June, and you can get back and see all of this content that you might have missed and kind of see what's going on in the community. Now, let me tell you a little bit about how we built this under the hood, just to give you another kind of flavor of how you can work with the Apollo MCP server. All right, let's get this out of the way. So I started in the, I started this with Supabase. And the reason I reached for Supabase is because I really like the way that they expose each table through PostgREST to make these REST APIs. Because I knew I wanted to use the REST API resources primarily just directly, that I didn't need to do a lot of management with these APIs. I didn't want to do a lot of management with these API results. I just wanted to use them from my database. So I was able to use Apollo connectors. And I'll show you kind of what that query that we just did for those events with the sessions connected, what that looks like in here. So I have my base URL for Supabase here, and you get one of those if you make a Supabase database. And then right under it, you'll notice I defined my event type. And I defined the fields that I want from that table. And then I also, you'll notice this, I added those sessions in. And what's really cool about this is event is its own table and own API, and so are sessions. But I'm able to orchestrate those two together into one query and one tool call, which is a much better experience, and it's much more efficient. So this is the kind of the background of that particular tool. And then down here, you'll see the actual get events query. Now, the other part of this, there were some things that I wanted to do custom. So this is, the REST connectors are really great if you have an existing REST resource, you just want to call it, map it to your types, use everything as is, but sometimes you do need to write your own logic, right? So you need to be a little more flexible. And for that, I used Apollo Server. Now, you don't need to see all that. This is teeny tiny. In Apollo Server, I made a JavaScript API. It's really lightweight. It's really basic. It's just for like the validation of the submissions right now. And I can add on to this as we have more needs. I'm not going to get into everything that I'm doing here, but this is for submission validation to manage those proposals that are coming in. And I used JavaScript and exposed it via Apollo Server as a GraphQL API. And now that schema that's pointing to Supabase, and this one can talk to each other and work together and be exposed as my tools. One thing to note, though, you don't have to use JavaScript here. We do have, if I could spell. All right, there we go. All right, so we have templates for lots of different languages. I know a lot of you are building in Python, or if you were better than me and started with TypeScript instead of JavaScript, I will probably migrate this at some point. We have all these templates ready to go for you, so you can, if you want to expose an API that you have to GraphQL to be able to layer it into the MCP tools via our server, we have a lot to get you up and running very quickly. And this will evolve alongside the community. One thing that I do want to call out is that this virtual session here that'll be coming up on the 14th, we're going to be layering in OAuth into that server as well. So we're building it with the community and alongside it, and then you can use it at every stage with every evolution of this server, which is really cool. So to wrap up about what you saw today, Apollo MCP server is fully open source. You can use it over top of any existing GraphQL API out there. If you want to build from scratch, you want to build more things, we do have REST API connectors, which are going to be the fastest way for you to expose a REST API to GraphQL. And we have Apollo Server to get you up and running with your APIs that bring some custom logic into that. So really, however you want to build, if you're trying to expose to GraphQL, which is a really great way to interact with agents, you can find kind of your path here and pick and choose what tools are best for your use case. And that's all I have, unless my hosts have any questions here.
Yeah, well, I don't really have any questions, but I just want to comment. I just think this is just so good. I've not seen this before. And I love the kind of the user experience and whatnot, but it really touches on some key things that like make MCP unique, or why you need to kind of even look at this layer, because like a lot of people, like initially when MCP was kind of like announced, people are like, oh, I'll just take my existing like open API schemas and turn it into MCP, or like I already have a database, I'll just fire SQL, you know. So
Yeah.
so what's really cool is this, like, you know, like what you guys did was, it's so slick and easy, but even just learning this pattern of, it's kind of like, look, our goal is really to get AI access to like the data and services we already have, but we have to build this intermediate layer that's almost more of like a use case driven layer, not a kind of a like raw fine grain. It's more coarse grain. So it's like your ability to kind of create these almost like stored procedures, you know, so it's, you know, be able to take a your existing data and then just form it into ways. So
yeah, it's just like nicer on the context window. You don't want to dump a bunch of stuff in there.
And but you really, because like what happens when you get down to building these tools is you really don't want to just be like, because some people are like, well, I'll just give AI access to everything and then magic will happen. And it's like, no, unfortunately, you really need to look more at like, what do you want the user to be doing? What are the end goals? You know, kind of like what are the, and then tailor the tools to those to give AI just what it needs.
Yeah, you really have to build from the user and agent experience now first.
Yeah.
You have to think of like, how are these two users interacting with that, and go from what they really need to function and what they're really looking for. And then, yeah, what questions are they trying to answer? And it's definitely, I'd say, yeah, it's a learning curve. I feel like I learn something new every day with like, even just like how to prompt Goose to get what I want as efficiently as possible. Like it's fun.
Yeah. And the cool thing also about MCP is, so it's like with your tool, it's like, oh, I can build these queries really fast, right? But it's like, oh, maybe I need to create these other MCP tools that have a little bit more code and logic in them. But with MCP, it's so nicely composable that it's like, oh, well, I could use, you know, the Apollo GraphQL, you know, MCP server, you know, for these things, because I just need quick data access. Hearing that you guys are adding OAuth is super cool.
Yeah, we're excited.
The next thing is like, what's the, you know, how to control that end to end. But yeah, I think it's exciting. Like, I think what you guys done is really neat. And then just that pattern, you can kind of extrapolate to a lot of other things too. It's just, you guys really hit on a good approach to this. So yeah. I was just neat. I just really enjoyed
awesome.
There. Yeah. Oh.
Thanks, Amanda. Well, hopefully we get some more late signups for your event this evening.
Yeah.
And you know, if people want to try it out, we'll add the link to everything in the description for the video.
Yeah, awesome. Thanks for having me.
Yeah, thank you for joining us, Amanda, and thank you everybody for tuning in today. This concludes this week's episode of The Context, but we'll be back same place, same time next week. Next week, we'll be talking to Daisy Health and MCP managers. So hope everybody can tune in again. Otherwise, have a great day. We'll see you all next time.